property. It's when you're in factored form and you're looking for what will make each of your factors equal 0. So number 1 is not too bad. X would just have to equal 3, right? Or if you wanted to make this one equal 0, X could equal -7. Right? That's the 0 product property. Actually, let me look at number 4 real quick. Because number 4, I know it's not odd, but it has a factor that looks a little bit different. It has 3x plus 2. And I might not be able to do that one in my head. So I can set 3x plus 2 equal to 0. And then I can solve that for x by subtracting 2 and dividing by 3. So -2/3 would be one of my x-intercepts. Now you do this other factor. If I have 4x minus 1 equals 0, how would I solve this other factor? So think about what you would do to get x by itself. How do I get x by itself in that other factor? So sometimes you can do it in your head and sometimes you can't. So I would add 1 to the other side and then divide by 4. So x would be positive 1/4 as my other x-intercept. And truly, these are the x-intercepts on the graph. So if I plug this in, thank you so much. If I plug this into my y equals menu, parentheses 3x plus 2 parentheses 4x, 4x minus 1, and I look at a graph of it, it's going to have x-intercepts at 1/4 and whatever this was, -2/3. I can't tell from the graph where they are though, unless I did like second calculate 0. So sometimes factoring is better than using the graph. Skip down to number 11 for me. They want you to factor number 11 and then solve it. On 7 and 9, you can just factor it, but on 11, they want you to factor and solve. This one is using greatest common factor. What is the greatest common factor in number 11? 11 and x. So I can divide both of these terms in the original problem by 11 and by x. What do I get when I divide this first term? Everything cancels, right? So I'm going to write a 1 inside my parentheses to show that all I would have left when I divide is a 1. And what about when I divide the second thing? -2x. You can distribute and solve, and you get 11x minus 22x squared. Morning. Okay, and that's equal to 0. So now I have to say, what does x equal here, and what does x equal here to make this true? 11 times what would give me 0? 0. So when you have an x hanging in front of the parentheses, you would just get 0. What about 1 minus 2x? I'm going to set that one up. Is that what it's going to be? To get x by itself, what would I move to the other side first? I would subtract this 1 to the other side, right? Let's see, let's do these steps out. 1 to the other side. Now I have -2x equals -1. Now how am I going to get this x by itself? If I'm multiplying by -2, I'd want to divide by -2 to the other side. Divide by -2. Looks like the answer comes out to positive 1/2 or 0. See how that's a negative divided by a negative, which is positive 1/2? And then this one was 0. 11 was probably the hardest one you'd see. Kind of having the 0 here. This is a little bit trickier. Okay, and then I'll leave you 13. I'm going to skip down to 19. Excuse me. 19 real quick. So, difference of squares was our other strategy we talked about. So some of these are difference of squares and some of them might not be. But you're looking for two terms. You're looking for a minus sign. And you're looking that these two terms are both in the list of perfect squares. So are 16 and 81 both perfect squares? the way you factor it, you put two binomial parentheses, and you take the square root of each of those terms. Square root of 16, so I would get 4x and 4x. And then the square root of 81 is 9. And then you give one of the parentheses a plus and one of the parentheses a minus. So this is a formula. Greatest common factor is dividing out the greatest common factor. This is a formula because this gives you back your 16x squared. This gives you your negative 81. And we get a negative 36x and a positive 36x, and there's 0x up here. So when I solve those for 0, what would I get? I'm going to get just the opposite answer. But on this one, I would subtract 9 and divide by 4. So x would be plus or minus 9/4. Because on this one, if I set this one equal to 0, I would add 9 and divide by 4. So can you try the other about 6 or 7 problems? Do just the odds on this page. So go back up to number 3. This is exactly what your homework is like tonight. 10, right? What would make this parenthesis equal to 0 when x is 10? So 10 is the solution. Some of you actually thought in your head, this means x minus 10 times x minus 10. So 10 or 10. You don't have to list it twice. But if there is an x-intercept like that, it'll just look like this. It'll be touching the x-axis at that one point at 10. You don't have to list it as two separate x-intercepts. You're not wrong. It's just, I just like to write x equals 10. On number 5, this 2 in front is affecting the steepness of your graph, but it doesn't give you another solution. On number 2, if there's an x out front, that gives you another solution. It gives you a solution of 0. But this 2, I can just kind of skip over that term and go to this parenthesis and solve for x. So if I wrote out, 4x minus 2 equals 0, my first step would be adding 2 to the other side, dividing by 4, x would be 1/2. And then if you went through that process with the other parenthesis, you would have gotten negative 2 as your other answer. Subtract 4, divide by 2. Let's see. So number 7, kind of a tricky one, but A is the greatest common factor. And you'll just have x plus y left. There was nothing to solve. You just had to factor that one. On number 9, it's a trinomial. And everything can get divided by 3 x's. So 3x goes on the outside. Let's see, you'd have 2x squared plus 3x and what, plus 5? I always double check. Yes, that gives me 6x cubed. Yes, that gives me 9x squared. And yes, that gives me 15x. So if I have to double check, you should also be double checking every time to make sure you didn't make a mistake with your factoring. Let's see, we did 11. Number 13, you can divide them both by 210, right? So 210, and all you have left is what, x plus 1? This one only has one solution because it's a line. Negative 1 would be the answer. This you really didn't need to factor, right? This is a linear equation. So you could really just subtract the 210 to the other side and divide by 210, and you'd still get negative 1. But it works for even that linear equation. All right, skip down to 15 and 17. One of them I can do, and one of them I cannot do. Which one can I not do? Why can I not do 17? Plus sign, right? So this one actually has no solution, or you could say that it's prime, I should say actually. Prime, because if I tried to factor it, maybe x plus 3, that makes sense in my head. When I multiply it out, I end up with this 6x term. So that is not equivalent to that. So x plus 3 is not the right answer. So it's just prime, but 15 you should have done x plus 7, x minus 7. And you did not go any further than that one. 17, 19, 21. Oh, 21 is also prime, right? So this one has no solution. And we talked about why some quadratics have no solution. What does this plus 100 do? It would shift it up 100. And it's concave up. Does it have any x-intercepts? No. So some of these graphs will have no solution. So those are the couple strategies we worked on yesterday. I'm going to teach you a new strategy today, but first, we're only going to do the diamond puzzles that have the X today, and we're going to save the diamonds at the bottom for tomorrow, so resist going ahead. But I want to show you what a diamond puzzle is. Have you ever seen these before? So a diamond puzzle is going to help us with our factoring in a minute, but we need to know how to solve a diamond puzzle first. They are giving you two terms here that you are going to multiply and put the product at the top, and you're going to add and put the sum at the bottom. So this first diamond puzzle, I'm going to multiply and get 70 and add and get 17. So the top row is pretty easy because they're giving you the two numbers. Let's go down to number 9. So 8 plus what would give me 11? 8 plus 3, right? Then I could do 8 times 3 to give me 24. Does that kind of make sense? So we're doing the ones that have the cross today, and then we'll do the bottom diamond puzzles as a warm-up again tomorrow. That way it's also helping our friends who are absent. They get like 2 shots at seeing some of this stuff. So you multiply to get the top, and you add to get the bottom. We're going to be using this to factor today. So just kind of getting used to what a diamond puzzle is, but please stop when you get to number 16. And we'll put our answers up in just a minute. You could use a calculator if you need to. See if this is working. So let's see. 8 times 1 is 8, and 8 plus 1 is 9, right? 5 times negative 4 would be negative 20, and if you add, you're at positive 1. This would be what, 7 and 8? 6 times 12 is 72 with a base of 18, is that right? This would be negative 20 with an 8. This would be what? Negative 12 with a 1. Positive 18 with a 9. This would be what? A 3 here to add, and then 36. This has to add up to 5. So would I have to subtract 5 here? And then negative 50. This would have to add up to 12, so I need an 11 here, and then an 11 on top. Sound good? This is 8 times 11 is 88, so 19 would go on the bottom. 4 plus 10 is 14, so 40 would go on the top. And then what did you say? 96 divided by 12 is 8. So then 9 is 108. I'm horrible at those two factors. 8 times 12 is 96. I usually don't ask them when they're that big. So let's see, this would have to be a positive 8 times negative 12, right? So negative 4. 4 times 1 with a base of 5. Okay, kind of understand how to set up a diamond puzzle. If you can do a diamond puzzle, you can do the next step of factoring, which you're going to learn right now. So turn to your resource page, R3-5 at the front, and I'm going to show you how to factor a trinomial. So we're only doing this next piece today. And remember, you don't have to flip, but I'll put it up here. But your factoring flow chart is on page 3.2. And your first step is always to pull out the greatest common factor. And your second step is to count your number of terms. 2 terms, you might have difference of squares. Today, we're going to have 3 terms. So this is on page 3.2. So the factoring flow chart, pull out your greatest common factor, then you decide if you have 2 terms or 3 terms. Maybe this is a difference of squares. Maybe not. Huh? This is you like the best? Because it's the easiest, do you think? Or you like it because of the kind of the puzzle of the factors? So it has to be a quadratic if you're factoring it. You have to have 3 terms, and the leading coefficient is always going to be 1 right here. So I didn't write an A because A always has to be 1 to use this method. We're going to see tomorrow what happens when A is not 1. Here's the directions, but I'll just show you what you're going to do. You're going to set up 2 parentheses because this is how you're going to write your final answer. You're going to put an X in each parenthesis because X times X is the only way to get X squared. So that should make sense, right? Then you're going to set up your diamond. The C value is -12. So -12 is what these 2 terms have to multiply to give you. The B term is 1 in this problem, 1x. So the B term goes on the bottom of your diamond. So you're looking for your 2 factors that are going to go here that multiply to give you -12 and add up to give you 1. So for example, 12 times 1 or 6 times 2 or 3 times 4. So what are the 2 factors that would win this diamond? Well, no, we're trying to get to -12 by multiplying, right? So 3 and 4 are my 2 factors because they differ by 1. And which one do I want to make negative? I want to get to +1. So I want the -3 times the 4 to give me -12. So this is a diamond puzzle where you're filling in all 4 of the spaces. But does that make sense? -3 times 4 is -12, and that adds up to 1. Those are your 2 things that go in your factors. -3 and +4. So let's try it for this next one. It's trinomial, so I know that I'm going to set up my 2 parentheses, put an X in each one, and then my diamond puzzle, I'm going to use a 1 on top and a -2 on the bottom. So what are the factors of 1, right? What times what goes here, so that the sum is -2. Yeah, -1 times -1 is 1, and that adds up to -2. So this is called, I wrote it down at the bottom here, B is called a perfect square trinomial. So the fancy way of writing this, if you really wanted to, is technically x minus 1 squared, but either of these is correct. Some people like to write it this way because it's one factor multiplied by itself. All right, this time I just put a couple examples where you factored it and solved it at the end. These were just factors. So I put my 2 parentheses, I put an X in each one, and I set up my diamond with a 32 on top and a 12 on the bottom. Here's where your math facts are super helpful, and some of us don't have our math facts all memorized. You can set up a factoring tree using a calculator if you're weak at this. I know that it would be 1 times 32, 2 times 16. On my calculator, I could divide. Ooh, 32 doesn't divide by 3. Ooh, but 32 divides by 4. Doesn't divide by 5, doesn't divide by 6. And then 8. Yeah. So one of those sets adds up to 12. So it's the 4 and the 8. But if you don't know the factors, take your calculator. Do 32 divided by 1, 32 divided by 2, 32 divided by 3. List your set of factors as a factoring tree. So I would want to choose 8 times 4. So x plus 8, x plus 4 go in the parentheses. And then it says equals 0. So what's my last step? X has to equal what as my solutions? -8 from this first parenthesis or -4 from the second parenthesis. Okay, last one on this page. So D, put your 2 parentheses, put your X in each, and set up your diamond. negative 8. So I'm looking for the factors of 16 that add up to negative 8. So 1 times 16, 2 times 8, 4 times 4. Which one would I want to use? Negative 4 times negative 4 to get positive 16, right? X minus 4, x minus 4. Again, I've got a perfect square trinomial. Nice to know. What does x have to equal as my final answer? So in this case, there was only one solution when x was 4, because this is a quadratic that's just bouncing off the x-axis at that x-intercept. I'm going to have some time to do a problem in groups. So let's just do like 2 more practice problems and then put it away for today. Your homework tonight isn't on the trinomials anyway. Take a look at the row at the very bottom of page 303 on the back. 303 on the back, just this one row of problems, 13 through 16. They use different variables. If you just want to use x, I don't have a problem with that, but they use just different variables. So try 13 through 16. And if you want to just start by, put your 2 parentheses and put an A in each one. Or for this one, you'd put your 2 parentheses and you'd put a C in each one. And then you're going to set up your diamond. I'll just set my diamond up on this page. This would be a 2. This would be a 3. This would be a 5. This would be a 6. So do up through number 16, and then you can pause. And we'll do a lot of those for practice tomorrow. Three assignments that are on quarter 2. So this should be what? Plus 2 plus 1. It doesn't matter what order you put them in. So if you put plus 1 and then plus 2, that's also correct. This would be what? Plus 5 plus 1, factors of 5. This would be x plus 7 and x plus 1. And I guess these were all the number and its factor of 1, right? This would be r plus 11 times r plus 1. All right, so I'm going to leave that for today.